So this is my video on absolute and conditional convergence. So take a series, any series, not necessarily positive, that can be a positive or a series with alternating terms, like the one that we saw when we did the alternating series test. So one of three things can happen. First of all, sigma an can and sigma absolute value of an can both be convergent, right? And the other possibility is sigma an is convergent, but the sigma of the absolute value of an is divergent. Okay. And the third possibility is sigma an is simply divergent. Well, in that case, we can formally show the proof is, I'm not going to do the proof here, that sigma an is divergent, that sigma absolute value of an is also divergent. Okay. So these three possibilities, one of these three must happen. Okay. So now, look at the first one. When sigma an and sigma absolute value of an are both convergent, we say that sigma an is absolutely convergent. When sigma an is convergent, sigma absolute value of a is divergent, we say that sigma an is conditionally convergent. And when the third possibility happens, when sigma an is divergent, we say that sigma n is divergent. There's nothing else, right? Okay. So one of these things will always happen. Either sigma an is absolutely convergent, or sigma an is conditionally convergent, or sigma an is divergent. All right, so let's take an example. So let's take our first example. Find out whether sigma 1 negative 1 over n is absolutely convergent, conditionally convergent, or divergent. Because one of these three things must happen. So what you do is, first of all, you check the first one, right? Okay, A. You check whether sigma an is convergent, right? So sigma an is sigma negative 1 to the power n over n, and it is of the form sigma negative 1 to the power bn, right? Where bn is going down and limit of bn is 0. So from the alternating series test, sigma an is convergent. No problems there. Okay, now want to check the other one, right? Let sigma n is convergent. Now let's check whether sigma absolute value of an is convergent or not. So if you take the absolute value of an, then you take the absolute value of negative 1 to the power n over n. So let's take a look. So negative 1 to the power n is something which changes between negative 1 when n is odd. So n is 1 is negative 1. If you put n equals 2, then you get negative 1 to the power 2, which is positive 1. If you put negative 1 to the power 3, then it's negative 1, and so on. It changes sign, negative 1, 1, negative 1. But if you take the absolute value of all this, it's always 1. So the absolute value of negative 1 to the power n is 1. And n is always positive. So this is just sigma 1 over n. But we know that this is divergent. So sigma an is convergent. Okay. So sigma an is convergent. But sigma absolute value of an is divergent. Now all you do is to check whether which branch this belongs to. So this branch is when sigma an and sigma absolute value of an are both convergent. So that's not that. So it's not absolutely convergent. It's what about this one? Sigma a an is convergent, but sigma absolute value of an is divergent, right? So this really belongs to this branch. It cannot belong to this branch, the first branch, because the third branch, because sigma an is convergent. It is not divergent. So definitely this belongs to this branch. So we say that sigma an is conditionally convergent. Let's look at another example now, right? So let's look at this example. Okay, so you want to check whether sigma -1 to the power n over n to the 5 is absolutely convergent, conditional convergent, or divergent. So likewise, we first take for a, we take the sigma a in the series. So sigma 1 to the power n over n to the 5. Once again, it's look like sigma -1 to the power n bn, right? Where bn is 1 over n to the 5. So that's decreasing and limits to 0, right? Okay, so by alternating series test, we know that this is convergent. Okay, so sigma an is convergent. So we can write on the side, sigma an is convergent. Now we look at sigma absolute value of an. Then you have the absolute value of -1 to the power n to the 5, because that's your an. And like before, we know that the absolute value of -1 to the power n is 1. And the absolute value of n to the 5 is n to the 5. So it's sigma n to the 5. But we know that this is convergent because we know that when you have sigma 1 to the power np, that is convergent when p is greater than 1 and 5 is certainly greater than 1. So we know that then sigma absolute value of an is convergent. So now we ask ourselves, which branch does this belong to? So if you look at our first graph, right, okay, sigma an and sigma absolute value of an are both convergent. So then we can say sigma an is absolutely convergent. So we can say that sigma an is absolutely convergent because both sigma an and sigma absolute value of an are convergent. Let's take a third example. Okay. Now in this example, let's consider a sigma 1 to the power n times n over n plus 1, whether it's absolutely convergent, conditional convergent, or divergent. Now we know from a previous lesson that for this the alternating series test doesn't work because the partner Bn, right, does not go to 1. It does not go to 0. As a matter of fact, this goes to 1. So AST does not work for this one. So what works, we also learned from the previous lesson, is a divergence test because the limit of this we saw, right? This is a sequence, right, which actually doesn't go to a limit because the even numbers go towards 1 because this goes towards 1, right? Okay, so this goes towards 1. So the even numbers go towards 1, but the odd ones, because of the negative, go towards -1. So it actually diverges. So an, right, really diverges. It doesn't go to a limit. So in particular, we know that if an diverges, right, then from the divergence test, right, sigma an is divergent. Okay, by the sigma test as limit of an doesn't exist. We know that when the limit doesn't exist, it is divergent right away. So for that, you don't need anything, no AST, nothing, just the divergence test, right? That will work. And we know that sigma an is divergent. So it's not conditionally convergent, nor is it absolutely convergent. It is simply divergent. That's it for this video. Thank you very much for watching.